Hello friends, welcome back to another exciting episode of podcast series Artificial Intelligence and Automation Testing and Software Testing, where we explore the latest trends in automation, AI and software testing. Today we are diving into how AI is transforming regression testing and predictive analysis, why this topic is matters. So regression testing ensures software updates don't break existing functionality, and AI can accelerate test execution and predict potential failures. So if you are exciting about AI driven test automation, make sure you to subscribe and drop your thoughts in the comment section. So let's start the podcast episode 4, AI for regression testing and predictive analysis. So agenda for today's episode is segment 1, what is regression testing, segment 2, how AI transform a regression testing, segment 3, AI for predictive analysis and testing, segment 4, real world case studies, segment 5, challenges and considerations, and in the segment 5 we will have the final thought and close. So segment 1, what is regression testing? So regression testing is a process of retesting of an application after changes have been made to ensure that new code updates don't break existing functionality. Why it is called regression testing? So the word regression means going backward or returning to a previous state. In a software, a bug fixes or new feature should not cause the system to regress into a faulty statement. For example, imagine you are working on a banking application. A developer fixes a small bug in login screen, but suddenly the transfer money feature stops working. That's a regression failure. So why is regression testing important? So first is ensure stability. Confirm that software updates don't break existing functionality. Improve quality. It finds uh, unintended bugs introduced by new code changes, reduce risk, so prevents costly post release failures, and last is enhances user experience to ensure that customer don't experience issue due to updates. So basically regression testing acts like a safety net. It ensures that we improve software, we don't break what was already working. So when is regression testing performed and how to perform the regression testing? So new feature added every time there is a code change, but let's break it down. So first is a new feature added, so testing to ensure that existing functionality still work. Bug fixes, if a bug should resolve the issue without breaking other part of the software. Third is code refactoring, so optimizing code structure without changing its behavior. Integration of new modules, so adding new API or third party integration or microservices. And last is performance improvement, to enhance the enhancement in speed or efficiency should not impact the functionality. So for example, if you think about any real life app, mobile app, each time an app updates, regression testing ensure old feature is still working. Without it, an update could break your favorite features. So what is basically difference between the manual regression testing and automated regression testing? So now how do team actually perform regression testing? There are two main approaches, manual or automated. So in the manual regression testing, suitable for small projects or UI focused applications, and but it is a time consuming and prone to human error. So how many of you still rely on manual regression testing? Maybe you can comment us on your experiences. Automated regression testing. So it is fast and efficient. It is ideal for the large applications. It reduces human efforts and minimize errors. It is also reuse test scripts for continuous integration. You can also see some of the best automation tools for regression testing like Selenium, TestNG, or Cypress. So automation is a game changer, but here is a problem. The traditional automation script also break due to the minor UI changes. That's where AI comes into picture, and we will talk about later in the next. So challenges in the traditional regression testing. First is time and resource intensive. So running in all the full regression should take hours per day, or multiple regression should be required. High test maintenance, so frequent code changes are also required. The updating test scripts, flaky test fail intermittently due to the UI changes or timing changes or timing issues. Test case prioritization, so hard to decide which tests are most critical in the regression testing. So have you faced these challenges in your testing? Let us know in the comment section. AI is here to solve these problems. In the next section, we will explore how AI speeds up regression testing and reduce maintenance test maintenance. So segment 2 is how AI transform regression testing. So now we understand what is regression testing and why it is critical. Let's dive into how AI is completely transforming the way we do it. And traditional regression testing has its challenges: long execution time, flaky test, and high maintenance cost. But AI is tapping into transforming this space. So in this section, we will explore how AI automates and optimizes regression testing, the role of self-healing test automation, how AI powered test selection and execution save times, and also we will see the real world use cases and AI tools making a difference. So AI powered test cases selection and priority, how AI selects test cases. So basically, one of the biggest pinpoint is the regression testing is decided which test case to run. Running the full suite every time is time consuming, and that's where AI helps. So how AI selects the test cases? AI analyze past test execution data, source code changes, and defect trends to prioritize and most critical test cases. And also AI can predict which area are most likely to break, reducing unnecessary test execution. So for example, imagine you are working in a travel booking website and the team makes a minor change to the flight search feature. Running all 5,000 test cases would take hours. So AI detects that only 200 test cases are directly impacted and prioritize to them. So we can save the 80% of the test execution time. So for this, best AI tools for test case selection, so you can use Mabl. That is also that is a AI driven test execution based on risk analysis, and also you can use testim.io, AI based test automation optimization for faster execution. These two tools we already discussed in my previous podcast, uh, episode 3. So basically, testers, how much time would AI powered test selection save in your workflow? Let us know. AI powered self-healing test automation. So how often you have automated test scripts failed due to minor UI changes? It's frustrating. AI can help solve this problem with self-healing test. So what is self-healing test automation? So traditional test script break you when UI changes, element changes like buttons, XPath changing, and also AI-driven test script automatically adapt the UI changes by detecting alternative example locators. For example, let us say you have a test case test that clicks a checkout button one day. The development team rename and button from checkout to proceed for payment. Just rename the button name. So normally your test would break, but with the AI, the test auto dynamically finds the right element and updates itself. No manual fixing is required. So to do this, best AI tool for self-healing test, you can use the Applitool Visual AI, that is for the AI powered visual testing and UI validation. Also, you can use the Functionize that uses AI to self-heal broken test script. So no more fixing broken test. Every Monday morning, AI does it for you. AI-driven test execution optimization. So another challenges in regression testing is long execution time. AI helps by optimizing test execution. So how we can do that? So how AI speed up test execution? So AI automatically parallelized test cases across multiple environment. AI skips redundant tests for unchanged modules, and also AI learn from historical failure to predict which tests are most valuable. So for example, if you are a retail company use AI powered test execution with test.ai, instead of running 10,000 test cases, AI selected the top 2,000 critical test cases and cutting execution time by 60% while maintaining test coverage. So best AI tool for test execution auto optimization. So you can use the Eggplant AI driven smart test execution, and also you can have Source Lab AI that is also uses ML to optimize machine learning to optimize test runs across environment. So next is AI powered self AI powered self healing test automation. So in this you can see AI for the visual regression testing. Sometimes even the smallest UI changes can cause big problems. AI powered visual regression testing help catch these issues. So what is the visual regression testing? So compare a screenshot of the UI before and after changes, and also AI detects visual shift that traditional automation might miss. So for example, a minor CSS update slightly move a buy now button and the functionality is fine, but visually it took off. AI powered visual regression testing detects and flags these changes before release. So for this, there are some best AI tools for visual regression testing. You can use the Applitool, that is Applitool I, and AI based image comparison for UI testing, and also you can use Percy by Browser Stack, and this is also AI powered uh, visual the differences of regression testing. So challenges of AI in regression testing. Still you are using that AI in the regression testing, basically AI isn't a magic solution. It comes with its own challenges. Let's discuss some key considerations. So one is AI models require training. So needs historical test data. You can also have the false positive and negatives. AI isn't always perfect. Human validation is still needed. High initial setup cost. So AI adopt requires, so basically, if you want to adapt the AI, you need to invest in tools and training. Best practices to overcome these challenges. So first is start small. So implement AI in a specific area first. Then after you can move ahead and increase it, or you can just enhance it. Keep AI model updated with new test data, and also use the human oversight to validate AI generated report results. So you just don't need to fully fully confident on the AI. You can also involve in the validation. AI can do a lot, but it won't fix your coffee machine when it breaks. So segment 3, AI for predictive analysis and testing. So now that we have seen how AI improves regression testing, let's take a step further. How can AI predict issue before they happen? This is where predictive analysis comes in. Imagine knowing which test will fail before even and even run them, or predicting which area of your application are at the highest risk of defects. That's the power of AI predictive analysis. So in this section we will explore what is the predictive analysis and testing, how AI model analyze pattern for forecast failure, real world use cases where AI predict bug before they occur, and the best tool and technique for AI driven predictive testing. So what is predictive testing? So predictive analysis is like looking into a crystal ball for software testing, but instead of magic, we use AI and machine learning to predict potential defect before they happen. So how does predictive analysis work? So AI model analyze historic test data, defect trends, and code changes to predict where failure are most likely to occur, and also helps prioritize testing effort, focusing on most at risk area of an application. So imagine you are working on an e-commerce application. AI analyze past sprint data and predict that changes in the checkout module have 70% of the introduced defects. Based on this, your team prioritizes testing that feature first and preventing potential issue before they can appear. So key benefit of the predictive testing. So first is early bug detection. So fix defects before they become major issues. Faster release cycle. So focus testing where it matters most, and cost saving. So it reduce rework by identifying issue early. AI models used for predictive testing. So but how does AI actually predict which test cases are likely to fail? And it all comes down to different machine learning models. So basically machine learning models for predictive testing. So one is supervised learning. AI learn from labeled past test data, that is pass fail history. And unsupervised learning, like AI detects patterns and anomalies in test execution results, and also enforcement learning, that is AI adapt based on the feedback from the previous test failures. So for example, if you see the example scenario, for example, AI detecting risky code changes. So let's say you are working on a bank application, AI can pass test execution result and see that whenever changes are made to an authentication module, 80% of the time it reduces a new bug. Next time the developer modify that code and AI automatically flag at it is a high risk and also suggest extra testing. So key metrics AI uses for the prediction. One is the code complexity. So more code complex equal to higher code or higher defect risk. Test failure history. So area of the frequent failure equal to more testing needed. And developer activity. So more changes equal to higher risk of the defects. Next is AI powered test case prioritization. So one of the most powerful application of predictive analysis in the testing is test case prioritization. Instead of running all the test cases, AI determined which tests are more critical. So how AI prioritize the test cases? So first is analyze past defect and test execution results. It detects patterns of high risk area, and also it ranks test cases based on the likelihood or failure. For example, AI predict bug prone modules. So in a large airline company use AI powered test case prioritization. AI analyzes their past test results and found that 90% of the critical bug appeared in the flight booking module. Instead of testing all features equally, they focus more resources where they're cutting testing time by 50% while still catching major defects. So for this, what are the best tool we can use for the test prioritization? So you can use the C lights, that is AI based risk analysis for test coverage optimization, and also you can use the launchable, that predicts failing test cases to speed up CI/CD pipeline. Next is AI for predicting flaky tests. So flaky tests are every automation engineer's nightmare, because sometimes they pass, sometimes they fail. Even when the code hasn't changed, AI can help detects and eliminate flaky tests. What cause the flaky test cases? So basically, unstable UI changes or AI elements, network latency issues, and timing related failures like tests running too fast before an element loaded. So how AI detects flaky tests? For this, you can use the AI monitor test execution history and flag inconsistent results. You can also uh, you, you can also see the AI assigns a flakiness score to test, helping team decide whether to rewrite or remove unstable scripts. For example, in the Selenium test, AI can fix the flaky tests. So in fintech company used AI powered flakiness detection on the Selenium test. AI identified that 20% of the test failed randomly due to the slow loading elements. By auto adjusting wait time, AI reduces false failure by 60%. So how to do that? So for that you can use the AI tools for flaky test detection. You can use Testim, that is a AI detects uh, that can detect the unstable test and also auto heal scripts. You can also use a SmartVR AI, that is also AI driven analysis for test reliability. Next is AI for detect prediction and root cause analysis. So what if you could predict defects before they reach production? AI can analyze code changes and detect defects before they even occur. So how AI predict defects? So basically, it can analyze the past defect trends and find recurring patterns. Also, it can flag code changes that resemble previous bug inducing modification. Also, it can suggest automated tests or manual review before the issue escalated. So, for example, you can in a healthcare company, it is integrated to the AI defect prediction into their DevOps pipeline. AI flagged recent changes to a medical data storage system as high risk, suggesting extra testing, and also make sure that the team found a major security flaw, avoiding a potential compliance disaster. So in this way, you can use this tool. So what are the tools we can use for the defect prediction? So for that, you can use the Microsoft Azure DevOps AI. It uses machine learning to predict potential defects, and also you can use the SonarQube AI, that is also a AI driven code quality and defect detection. So these tools can prevent the defect prediction. So next is challenges in the AI in predictive testing. So AI sounds amazing, but it's not perfect. Let's discuss how some of the challenges teams face when using AI for predictive analysis and testing. So one is data dependency. AI needs a large amount of past test data to make accurate prediction. False positive. AI might flag low risk changes as high risk, and also the complex setup it initially implementation required for the effort and expertise for the predictive AI, and how we can overcome these challenges. For that, you can use start with the small AI driven pilot projects before scaling. Continuous train AI models with updated test data and combine AI insights with human judgment for better decision. So AI is a smart, but let's be real, it won't replace human tested intuition anytime soon. Segment 4, real world example and case studies. So let's talk about some real world companies using AI in regression testing and the impact it has had. So case study 1, Facebook's AI powered regression testing. So Facebook uses AI based test selection to reduce redundant tests by 70%, and their AI system predict unstable test cases before execution, improving CI/CD efficiency. Next is case study 2, Google's AI for self-healing test. Google developed an AI-based self-healing framework for mobile app testing, and it results 50% of reduction in test maintenance effort. Next is case study 3, the fintech company using predictive AI. So a major fintech firm used AI to analyze past defects and predict future failures. So this will reduce the critical bug occurrence by 40% before production. So would you like to see more case studies in future episode? Let us know. I will create a new videos for that. Next segment is challenges and considerations. So we have seen the incredible benefit of AI in regression testing and predictive analysis, but let's be real. AI isn't perfect. It comes with its own set of challenges. In this segment, we will break down the most common roadblocks teams faces and when implementing the AI in testing and how to overcome them with best practices. So in this section, we will cover key challenges in AI predictive testing, real world example for failure and lesson learned, best practices for effectively integrated AI into your testing strategy, and also future trends in AI for testing automation. So key challenges in AI powered predictive testing. Challenge 1 is data dependency and quality issue. So AI in testing sounds great on paper, but what happens when it doesn't work as expected? Let's look at some real world challenges teams faces. So challenge 1 is data dependency and quality issue. AI models depend on historic data to make accurate predictions. If your test data is incomplete, biased or outdated, AI can produce misleading results. For example, a banking app uses AI for data test prioritization, but because most past defects were logged for the web version, AI ignored mobile app testing, leading to critical bugs slipping into the production. The root cause: AI was trained on biased test data that didn't represent the mobile testing. So, best practices for this: ensure AI models are trained on diverse, high quality test data covering different platforms, scenarios, and real world edge cases. Next challenge is false positive and false negative. AI may flag changes as high risk when they are actually safe, false positive, or miss actual issues, false negative. For example, an AI driven test prioritization tool marked every changes in a legacy ERP system as high risk, forcing testers to spend unnecessary time running redundant tests. Developers soon started ignoring AI's warning, reducing its effectiveness. So, best practice for this: you can fine tune AI thresholds and combine AI predictions with human judgment to ensure smarter decision making. Challenge 3: resistance to AI adoption. So, many testers fear AI to replace manual tester, leading to a resistance to adoption of or in a QA team. So, for example, a software firm introduced AI powered test case generation tool, but manual tester resisted using it because they felt it would replace their job. The result: the AI tool was never fully adopted. So, best practices for this: educate teams on AI's role as an assistant, not a replacement. Start with a small AI driven project to build trust, and also involve testers in AI model training to ensure human expertise guide AI decisions. Challenge 4: AI's black box nature, lack of explainability. So basically, AI can make decisions without clear explanation, making it hard to trust. For example, developer struggling with AI's unclear test case suggestion. A CI/CD pipeline used AI to auto prioritize tests, but developers struggle to understand why some test cases were skipped. This has led to skepticism and distrust in AI decisions. So, best practices for this. So, choose AI tools that provide explainable AI, that is XAI, and basically the models that show why they made a particular prediction. Keep human oversight to verify AI decision before acting on them. Next is AI maintenance and continuous learning. AI models require ongoing training. They don't stay accurate forever. For example, AI model degrading over time. So an AI defect prediction system worked well for 6 months, but as a software evolved, it stopped detection new defect patterns, leading to a decline in accuracy. So best practice for this: regularly retain AI models with the latest test data and monitor AI performance and fine tune parameters over time. So now we have seen the all the challenges which we can find using AI, but the best practices to overcome those challenges. Now that we have covered the challenges, let's talk about how to implement AI in testing the right way. These best practices will help you get the most out of AI while avoiding common pitfalls. So, best practice one: a small start small and scale gradually. So, don't try to automate everything at once. Begin with low risk AI driven test optimization and expand as AI proves is its value. For example, AI powered regression testing pilot. So a retail company first uses AI to optimize regression test selections, saving 40% test execution time. After success, they expanded AI to defect prediction and flaky test detection. Best practice 2: balance AI with human expertise. So AI works with when combining with human intelligence. It works best when combined with the human intelligence. QA engineers should review AI predictions instead of blindly testing them. For example, combining AI insights with a manual testing intuition. An AI model predicted that login page changes were low risk, but a senior tester flagged potential security vulnerability. Their combined insights helped catch the critical bug AI had missed. Best practices 3, that is continuously improve AI models. So AI isn't a set it and forget it solution. Continuously retrained it with the updated test execution data to maintain accuracy. For example, AI adapting the new software updates. An AI test optimizer started off with 85% accuracy, but a new feature were introduced, its accuracy dropped to 65%. After retaining with fresh test data, the accuracy can improve to 90%. Next is best practice for choose the right AI tools. So select AI powered testing tools that align with your tech stack and needs. So best AI tool for predicting testing: C Light AI driven test impact analysis tool. Launchable, it is AI based test case selection for CI/CD pipeline, and test IM, that is for AI driven test automation with self-healing script. So have you tried AI power testing tool? Which one works for you best for you? Let's comment out. Future trends in AI for testing and automation. emerging trends. So before we wrap up, let's take a peek into future. Where is AI powered testing headed? So emerging trends: self-healing automation, AI automatically fix broken test scripts, AI powered test data generation, AI create test data based on the real user behavior, autonomous testing agents, AI bots execute and analyze test without human intervention, and AI augmented testers. Future testers will work side by side with AI assistants to improve efficiency. So, do you need do you think AI will eventually replace manual testing, or will human tester always be needed? Let's hear your thought. So, so now we are reaching to the final segment, final thoughts and call to action. So we have covered a lot in today's episode: AI's impact on regression testing, predictive analysis, challenges, and best practices. Before we wrap up, let's take a moment to reflect on the key takeaways and where AI is testing is headed. To wrap up today's episode, let's highlight the key takeaways from today's episode. AI in regression testing. So AI helps prioritize test cases, detect flaky test, and optimize test execution. AI-driven automation reduces execution time, maintenance overhead. AI-powered visual testing detect UI regression with higher accuracy. Predictive analysis with AI. AI can analyze past defects and predict potential failure before they happen. Machine learning Machine learning modules identify high risk area to focus testing efforts efficiently. AI powered defect analytics improve root cause analysis and faster debugging. So challenges and best practices. So challenges: AI needs high quality training data to make accurate prediction. False positive, false negative can impact trust. Human oversight is crucial, and continuous learning is required to keep AI model effective. So best practices: start small, don't automate everything at once. Use AI as an assistant, not replacement for the tester, and continuously update AI model with fresh data. So where is AI is testing where is AI in testing headed? Before we end, let's take a look at the future of AI in testing. Where is this technology heading and how will it evolve? Future trends in AI powered testing. So self-healing test automation. AI will automatically fix broken script without human intervention. AI augmented test engineers. AI will assist testers in writing test cases, analyzing results, and optimizing coverage. Autonomous testing agents, AI driven bot will execute end-to-end tests independently and require minimal human input. Explainable AI, XAI in testing. Future AI models will provide transparent decision making to improve trust. Generative AI for test case generation. AI will generate complex real world test cases based on user behavior analytics. So, what are your thoughts on the future of AI in software testing? Do you think AI will completely take over, or will human tester always be needed? Drop your thought in the comment section. So, what's next? In the next episode, we will dive into AI powered test data generation, how AI can generate complex test cases without manual effort. Don't miss it. So if today's episode gave you insights, don't forget to like the episode to support our content. Subscribe to our channel so you never miss any update. Share this episode with your team and fellow testers, and also comment below with your biggest takeaway from the today's episode. Thank you.